So welcome back, and welcome to the new attendees. Some quick event logistics, just so you know. You have wireless internet cards on each one of your seats. If you haven't already, it's your own code to get on the internet. We have some Microsoft staff here to assist you. They're over here in the black shirts. We call them the Ninja Squad. They can be here to answer any questions, and especially helpful for the hands-on lab. Like I said, we have live stream and video recording. So later on, if you want to access the recording, we'll make it available to you. Lunch will be from 1 to 2 p.m., and it will be served in the restaurant down the hall. So we'll be making a left, and go ahead straight, and you'll see the restaurant there. We'll have an afternoon coffee break from 3:30 to 4. Please come back on time from the coffee break and lunch, because we'll get started right away. We have a lot to cover today, so we really want to make sure that we stay on track. Tomorrow, hands-on lab. We'll do a little bit of it today, but tomorrow you'll really get your hands on building a Windows 8 app. And feedback forms. So for those of you that will not be attending tomorrow, please make sure that you submit your feedback forms to us. It's important for us to know how we're doing and how we can improve to make your experience even better moving forward. For those of you that will be here for tomorrow, you can submit your feedback form tomorrow, end of day. Just a rough guide to the agenda for today and tomorrow. Obviously, we'll discuss the platform, the UI, and obviously the Microsoft Store. How many of you have not downloaded the lab assets for the hands-on workshop? We sent you an email. If you have not downloaded the lab assets, come see me. We will provide them for you because it's important for you to really get the hands-on experience. Visual Studio 11. So most of you have downloaded it. Yes, I hope, because you will need Visual Studio 11 to get your hands on a Windows 8 app building. But if you don't have Visual Studio 2010 and you want to get ready for the new release, there are some things you should know. First of all, prices will increase. So if you don't have Visual Studio 2010, now is the time to get it. You will obviously have the next version at release. So by getting 2010, you're just getting ready for Visual Studio 11 because you're locking in those low prices. Okay. We do have some discounts now because we're getting ready for Visual Studio 11. So we have some promotions and discounts for 2010. How many of you are using Visual Studio 2005 or 2008? Okay, so if you don't have MSDN, you may be eligible for some price discounts. So if you want to know more, come see me either at the coffee break or at lunch. We can talk about if you can get 15 or 35% off Visual Studio 2010. So not only will you lock in lower prices, but you get a discount, so it makes sense. And if you have a MSDN subscription that has expired before July 1st, 2011, then also you're eligible as well. How many testers are in the crowd? Do we have some testers out there? We do have 20% off Test Professional for everyone. Okay, so all of these offers end at the end of June 30th of this year. So it's a really good opportunity for you to save some money and get ready for VS11. We are very happy to announce our Gulf Windows 8 app competition. So not only will you get the training in these 2 days, but you'll have a chance to actually win a Samsung Windows slate. So you have the little one-pager there on your seat. You can take that with you. But the best Windows 8 app will get the Samsung tablet. How many have had their hands on one before? Just a couple. Well, the experience is amazing. So I'm sure a lot of you all are very excited to submit for this competition. But I know you're asking, so what is the best Windows 8 app? So for us, the judging criteria would be 60% creativity, originality. So not an out-of-the-box app that, that is very common, but something creative and original, 60%. Relevance to the local market, 20%. So one of the things we're very proud about for our Windows Phone is that we have a lot of local apps. You know, we have Timeout, we have mPark. So, you know, relevance to the local market is very important. And then practicality for the end user, that's pretty obvious, 20%. If you want to submit more than one application, feel free. We will accept unlimited entries per person. So all you need to do at this point is submit your app description to this email, appsubmission@microsoft.com. Since we do not have a marketplace, because it's not officially out yet, we will need to be a little creative. So you can send either screenshots of your app or a demo video showing how the functionality of your app and how it works. It's up to you. Neither one is better than the other. It's just a choice for how you would like to submit. Your deadline, 25th of June. So you have just a couple months here. And I'm sure after the next couple days, you'll be able to create an app in no time. So good luck. Any questions, either about the offers or about the competition, feel free to email us at vs11golf@microsoft.com and have an excellent event. So that's all I have for you at this moment. I would like to introduce our speaker. We are very excited to have him here with us today. He's Senior Director of Development and Platform Evangelism Group for Microsoft Corporation. He comes all the way from Redmond, USA, and he leads the definition and provision of strategic technical evangelism support for cloud computing and devices in the consumer industry. He's worked on developer tools, languages, and support for mobile phones, embedded systems, game systems, stores, and marketplace, and most recently, tablets. So everything you can think of. He has more than 35 years experience in the industry. It's experience in technical pre-sales, consultancy, research, development, manufacturing, testing, and assurance in a wide variety of senior leadership and management roles in both the field and product environment. 18-year veteran in Microsoft. And before Microsoft, he was 18 years at IBM UK. So I would like to invite Michael Platt.
Thanks very much.
You're welcome.
Good morning, ladies and gentlemen. Welcome to today's event, the next 2 days, in fact. And thank you very much for coming. It's great to see so many people interested in Windows 8. It's a very exciting event for us, a very exciting time for us. And it's, on a personal note, it's nice to be back in the Gulf. I was actually born and brought up in Kuwait, and in fact had my first job over in Bandar Abbas, just on the other side of the Gulf, so out back under the Shah. So it's nice to come back. It's changed an awful lot from when I was born, I have to say. Not very much. It stays the same, except the sand, I guess. Anyway, so it's great to be back here. As Maureen said, now I work over in Redmond, and I look after the consumer side of things, really, for developers. So I decide and try and make sure that we have the right thing in place for developers on the consumer platform. So that's our games platform, obviously, the Xbox side of things. It was the phone until recently. I actually don't own the phone anymore. That's gone off to another person. And then more recently, it's been things like Marketplace and the tablet. And I've been working on that for about 10 years now, I suppose, 8 to 10 years in Redmond. It's been a very interesting, exciting time. Before that, I was actually in the enterprise side of things in Microsoft. And we as an industry, we sort of swing backwards and forwards between consumer and enterprise in terms of focus. So originally, of course, I was at IBM, very enterprise focused. I came across to Microsoft and then moved back onto the consumer side because I could see that really there was a lot of interest growing and momentum even 10 years ago around consumer computing. Obviously the phone, we know where what's happened in that space, and now more recently in things like the tablet and the games. So it's been a very interesting 8 or so years trying to get Microsoft, back into the consumer space and try and build more and more consumer presence, more and more consumer applications, and make sure that we have the right applications in place. So what I'm going to talk about for the next couple of days has really been something I've been working on for a long while. We're trying to get it I've been trying to get it as close to what I believe that developers want as possible, and at the same time move the platform forward. So that's really what I'm going to be talking about. Now, Windows 8 is really two things. It's actually the conventional Windows 7 that we all know and obviously use every day and so on and so forth. So we still have all of Windows 7 there. And in fact, in many ways, Windows 8 is better Windows 7 than Windows 7 is. You'll find that it's faster, uses less power than Windows 7 does today. But of course, there's the other side of things, which is the Windows 8 tablet side, which we're calling Metro. And the Metro is really our vision for where things are going in terms of tablet computing, and both from a consumer's perspective, from the user's perspective, and also from the developer's perspective. So I want to talk a little bit about what we've seen happening and why we think we need to make the changes we're making. This is actually a very major change for us, Windows 8. It's the first time we've changed the UI since Windows 95, so that's 18 years ago. And of course, the major change before that was Windows 3.1, to give you an idea. So probably every 15 years or so, we change the UI. And this is the version where we're changing the UI. And as I say, the reason we're doing that is we believe that there's a whole area of different things come together more or less at the same time. And that's caused us to say, okay, now is the time for us to build a new front version of Windows, which is this whole area of Metro. And the things that have come together is, first of all, we still have a huge PC business, and we mustn't forget that. We've sold in the last 18 months something like 500 million copies of Windows 7. So, and that's by far the biggest number of sales of any operating system. Even in fact, if you put all the other operating systems together, it doesn't come up to that sort of number. So Windows 7 has been hugely successful for us, really massively successful, in fact, especially following on from Vista. So we're very happy with that, and of course we've got to make sure that that moves forward. And one of the key things I hope you'll get to understand in this is that we have to hold together two things from a supplier's point of view. First of all, we want to make sure that we can still support what's happened in the past, and in particular the skills that you have as developers. But at the same time, we have to provide new functionality, new ways of doing things, without making your skills out of date. And it's been an interesting challenge to say, okay, how do we make sure that people's skills, people don't have to go out and learn everything from new, but at the same time we can build a platform which is ready for the next 15 years. And as I say, Metro is our version for that. So it's how do we make sure we can still support both Windows 7 plus all the tools and techniques you're used to, obviously Visual Studio, but also things like XAML, HTML, and JavaScript, and the different languages, obviously C++, C#, and JavaScript. So we have to support all those things, but at the same time we have to provide a new platform. So that's one area. The other area is, of course, the whole area of the hardware and what's been happening in hardware. Hardware's moved very rapidly because of the smartphone business. Obviously, the growth of the whole ARM side of things and people's usage of ARM and the tablets that are associated with that and the phones that are associated with that and the touch type interfaces that are associated with that. So we've seen a lot of changes in the last 5 years in terms of what the hardware can do. And we will actually see that accelerate, if anything. And we have to make sure that the platform supports that. It also supports all the new sensors that we're beginning to see. Clearly on a PC, sensors are less applicable than on a tablet. But when you get onto a tablet, things like accelerometers, GPS, compasses, all those things are going to come in on the tablet. We need to make sure that the OS supports those And by the way, the OS supports those in such a way that it makes it easy for the developers to develop, and that we don't have all the sort of problems that we've had in the past with device drivers. So there's that side of things is what's happening in terms of the hardware. And then finally, there's what's happening in terms of people's what people want and what people understand and what people's usage patterns are. And again, what we did 15 years ago was valid 15 years ago, but now with the sort of numbers of computers that are out there, the usage of those devices, the prevalence of those devices, it means we need to make sure that the operating system is much more secure, it's much more locked down, that people understand what's happening in the machine, and that the programs can't go and change the machine or change the applications on the machine. We need to make the machines much more robust and much more, people have a much better confidence in the way the machines work. So whilst people are using the machines much more in day-to-day life, we also have to provide much more stability, reliability, and so on and so forth. So there's a whole range of different things we've had to build in to Windows 8, and in particular into Metro. And so that's what I'm going to be talking about today. I'm mainly going to be talking about the Metro side of things. I'm not really going to be talking about the Windows 7, the desktop type applications. They stay very much the same. As I said, they do get slightly better in terms of performance and reliability and battery usage because of the work we've done in Windows 8 itself. But in general, that stays much the same. And I'm going to focus in today on the Metro side of things, the new UI. So let's go and have a quick look at that for starters. And this is Metro. You've probably all seen it. And I want to call out a couple of things before we start. First of all, it's a very interactive experience. Okay? We looked at what we want to have in terms of an experience. Clearly, we've got to have a much bigger button space in order to touch and to be able to click on something than you have in the past. But we actually want the whole experience to be much more interactive. I mean, we could very easily go out and build these buttons just to be application click buttons. We actually had that in Windows 3.1, in fact. I mean, if you remember back to Windows 3.1, you had all the little buttons, and you could click on the button, and up would come the application. We actually feel that that's not a particularly good model for the next 15 years. We actually have to think in terms of next 15 years, and we believe that for the next, if we're talking about an operating system for the next 15 years, we need to have much more interactivity. Those buttons, those application launchers like we see here, you've got to be able to interact with those and much more dynamically. We need to be able to put up pictures, we need to be able to put up information. They need to be able to interact with the user. And you can see here, some of these are changing, things like my mail, my photos, they're changing interactively. You can see that some of them, for instance, have information coming up and telling me that I have a mail, that I have some updates from the store. So various information comes up. So first of all, we believe that we've got to build something that's more than just a set of applications. We've got to build something that provides a lot more functionality. And that's what we see here. The second is we need to provide a very fast and fluid experience, in particular for touch. So you need to be able to do this sort of activity to find the applications. So I'm just sliding backwards and forwards. You can see how fast these move. So I can actually select things very, very quickly. I can move across all the applications I have very quickly. And then, of course, I can go and actually click on a particular application and launch it very easily. So let me just go and do a game to start off with. And this is actually a pinball game. This is actually written with DirectX. And I just want to give you an idea of the sort of graphics you can get with... in fact, this actually works on a fairly low... This is quite a powerful machine, but it does actually also work on a fairly low-powered machine. You can see some pretty impressive graphics, 3D graphics going on there, using DirectX and C++ and C++. So that's a sort of game application. Of course, there's other applications like a news application like this one from MSNBC. Again, you can scroll through the news very, very quickly. You can actually pick particular pieces of the news. And this is the second thing that we want to have, is to make the whole experience very personal. So that, for instance, you can actually say, OK, I'm going to pick a particular, going to have a look at a particular article here on Windows Phone, and maybe say I want to actually go and pin this to my start bar. And so now I have it as an application on my start bar. And I go back in here, and where's it gone? Here it is. Okay. This is the application. It's a technology application. And I can take it. I can just drag it somewhere else. And so I can actually personalize the screen very simply for myself. I can also actually this is simple. This doesn't have very many applications on this machine. If I have a lot of applications, clearly I need to be able to group those. And so I can do things like what we call semantic zoom, where you can actually take a group, make that group smaller. Perhaps I want to name the group. And so I'm going to call this demos, because later on we're going to be using these as demos. And I can name those as demos. And I can actually then work on a much smaller area. And actually have those configured as well and start to be able to do grouping and so on and so forth. So first thing, obviously a very dynamic experience. The second thing is a very personal experience. We can make the whole of the UI exactly what we want. We can put up the information we need. We can select and generate new applications very simply, all built into the operating system, all part of the operating system. Now, of course, the thing that's missing on this is the whole area of control. You know, how do we go and do the standard sort of things that we need to do on our PCs day to day? Things like the start information, the Chrome that you normally see around in a Windows environment. And this is a key thing, because we actually believe that the important thing going forward is going to be the content rather than the controls around the outside. So we're actually trying to build a system which has the minimum amount of control, and the controls are automatically in a place where people know where to go and look. And that's always the same no matter what they're doing. This is good because it means you have a smaller tablet, for instance, smaller tablet form factor, then you're not using up the screen real estate with things that are not really doing anything of any great value. So a great part of Metro is this whole area of content and data over Chrome, trying to get the maximum amount of information on the screen that people want, and keeping the extraneous information off. So to give you an example, for instance, we have this thing called the Charms bar here on the right-hand side. It allows us to go and obviously do things like machine settings, for instance. But it also allows us to go and, this is my start button, which goes back to the start screen. Okay. But we can also do things like sharing and search, go and have a look at the devices we're using and so on and so forth. And I'm going to be drilling into a lot more detail around search and sharing in particular, because we think these particular things are very important. In particular, the search, we believe obviously search is important. Search across the internet is very important. We understand about search engines. We have Bing, of course, our own search engine. But we also realize that people want to search on their own machines. They want to search into the file system, but in particular, they want to search into the applications as well. People may have information in an application is holding that they need to be able to go and find. So I'm going to be talking a lot about how we can implement search inside our applications, and that then actually interacts with the operating system and comes up as part of this search button. And then the same thing's true with share. I think actually share is a very important area. I can remember back in the days when we didn't have cut and paste, copy and paste. And trying to move things from one application to another was a big problem. Now we're all very used to cut and paste. In fact, if cut and paste isn't in an operating system, people complain and so on and so forth. Sharing actually is like cut and paste, but a lot further ahead, insofar as you can actually share different formats, different types of data, different image, and so on and so forth. You can share those, and you can share those between any application in the machine. So I'm going to be talking a lot more about the share side of things. So that gives you an idea of what the Windows Charms bar looks like. It always comes up no matter where you are. It allows you to go in and change whatever you need in the machine. Obviously, as I said, it changes the machine settings. But it also, of course, works inside the applications themselves. So, for instance, I have a cookbook application we're going to be looking at in a lot of detail later on today. And we can pull up the charms inside that as well, and we can go and have a look at the settings for that particular application as well. So these things exist also inside the application, but they're context sensitive. when you're in a particular application, they understand that they provide back similar but not the same information. The other thing that we have that talks about the right-hand side of the screen. We also, of course, have the other sides of the screen. So down here on the bottom, we have the application bar. This is actually at the bottom and the top as well. And the application bar allows you to put in application-specific information. So obviously here we have the home, but we can go in, for instance, to a particular menu, and we can do things like pinning. We can set reminders up. So these are things that you as application developers can go and use. You can use this bar. It belongs to you. You can put whatever you like on it. And I'll be talking, again, in a lot more detail about the application bar and how you use it. And then finally, actually, over here on the right-hand side, we have the ability to go through all the applications that we have running on the machine. So you can go and see, I can just go and flip through everything that I've opened, and they exist here, over here. You can actually see they come up with little versions of it over here as well. You can see all the applications that I'm running, and I can just go and click on any one of them, go straight to it. You can see the sort of quality that we're talking about for these applications. So that gives you a quick overview of what the Metro looks like. Just to reiterate, the right-hand side is going to be the charms, how you control your application, the machine itself. The bottom is your application-specific settings. Left-hand side is all the applications that you have. You can also split the screen, and you can have multiple things up on the screen at the same time. You can do some other things, and we'll go into, again, in much more detail about how that's all done. But the three things I want you to take away, I guess, from this particular demonstration is, first of all, Metro, fast and fluid, very interactive, very dynamic. The second is that it's personable. You can change it very simply to whatever you want, put any applications up you want, use whatever you want, and make a very personal experience. And then the third thing is that you can control everything with the sides of the screen, right? And as I say, I'll be talking in a lot more detail and, about actually how that's all done, right? Okay, so going back to the slides. So we actually think that Windows 8 is Windows reimagined, right? That is, we're now rethinking about what the operating system should look like, and we're trying to meet all the requirements for the next 15 years in terms of hardware, in terms of base operating system and the skills that people have today and want to reuse, and then finally how people are going to use the machines for the next 15 years across a wide range of different scenarios and usage patterns. So we believe that this is the time when we should go and rebuild Windows, and as I say, that is what Windows Metro is all about. Okay, so that talks about the user experience, gives you a quick run through some of the user experience. I now want to talk about what we've done for the developer side of things and how we as developers can actually build things that fit in with this sort of model. And what the actual underlying platform that creates these applications is. It's called Windows RT. And the investments we've put in is, as I say, this new Windows runtime. Okay? And we've gone and we've re-looked at Windows at a developer level, and we said, okay, what do we actually have to do in order to give a really good, solid developer experience? And that developer experience should be common across any language. It should be a standard set of APIs, and it should be simple to use. And then finally, of course, you should be able to reuse your skills and your languages on top of this going forwards. Now, it doesn't mean to say you necessarily can use exactly the same code. You can't take a piece of Windows 32 code and run it against this, but the skills you have, if you've written it in C++ or C# or whatever, can be reused. And as I say, we'll go through the Windows RT APIs in some detail. It will give you an idea of how we've tried to make this as close as possible as today's experience, and at the same time provide it as a native experience as possible. So you get the sort of advantages you get with native code in terms of performance and flexibility, but at the same time, we provide a lot of the management side of things that you need as well. Obviously, once you've built your application, you need to execute it, and so we provide a new application execution environment. And in particular, we realize that we need an execution environment which is a much more managed environment. I'm not talking about managed code. I'm talking about making sure that people know when they load down an application what that application is going to do to the machine, and it doesn't do anything else. Right? So we need to make sure that you can go and download a known good package onto your machine. That package is installed. That package only changes the things it's meant to change. People are very confident in what they're loading. One of the biggest problems today, without a doubt, in Windows is that people don't want to load things because they don't know if they're valid or not. You know, they don't know if they're malware, if they've got spam in them or whatever. And they're very well aware of that. So people are very nervous about loading things. And we need to take that away. And we need to make sure that this application environment actually provides them with much more confidence in their machines. And indeed, by doing that, we make the machines much more reliable. We don't have this awful business where the machines become slower, the machines don't work very well, and so on and so forth, because people have loaded their applications down, and those applications are then doing things on the machine that they shouldn't be doing, or indeed, they've gone and installed additional elements on the machine, which is slowing the machine down, and people aren't realizing that. I think we've all had experience of going and having to clean up machines and take things off them, and we're really trying to cut that back and make sure that we don't have to do that anymore. I've talked a little bit about the experience. We obviously need to support that new experience as developers. We need to make sure that what we build fits in with this user experience. It fits in with the other elements that you have as part of Windows 8. And then finally, we need to provide a store. So the whole area of marketplaces and store, obviously a key part of the application, the execution area, is to generate the ability to store your applications, and then people download those applications and pay for those applications. We need to provide the sort of wide range of business models that people are expect today: advertising, in-app sales, in-app upgrades, all those sort of things, trialing. All those things need to be provided, and they need to be provided by a store, and we will provide that Windows store. So we're going to be talking about all these things in much more detail, both later in this session, and then later on in the day we'll go into details on how you program to the WinRT, how the new application environment works, how you build things for the new user experience, and then of course the store itself. So let's start off by having a look at the Windows RT and what the platform looks like. First of all, we have the standard Windows OS services down at the bottom end here. This is actually exactly the same as we have in the desktop version. So these are the old Win32 APIs. They're still there. So if you're in the desktop version, and your applications will all still work. They still use those standard core services underlying it, and everything works fine. And so today, again, in terms of the desktop, if you've got a Silverlight application, or Win32 application, or an IE-based application, those will all work. And one of the things we have done, which isn't shown on here, is that we've provided as a close as possible connection between the hardware and these higher-level services. So even if you use HTML JavaScript today in IE10, then we do a lot of hardware assist. Your JavaScript will go, and actually a lot of it will actually run straight in the GPU in the hardware. So you get a big performance improvement even over where we are today. So wherever possible, we're going to push more and more support down into the hardware, both in the standard desktop applications, but of course also in Meta applications as well. A couple of things I want to pull out here. First of all, there are to us there are three languages, right? There's the C# and VB managed languages on top of .NET today. There's C and C++ languages, and there's HTML and Java. Well, HTML is not a language, but a JavaScript language. And we believe that those are the languages people are familiar with and program in today. And actually, that's where most people have skill sets. So we will continue to support all those three things. This is really, really important. We will continue to support C#, XAML, HTML, HTML5, and JavaScript. So people who say, "Oh, what are we going to do about Silverlight?" We will, if you have XAML skills and C# skills today, we will support you. Absolutely. These are one of our number one platforms, one of the three number one platforms. So we will continue to support you. As a matter of interest, how many people here are C# developers? C# XAML? That's what I thought. How many people are JavaScript? HTML JavaScript? Oh, that's good. How many people are C++? I'm C++. So we do very. I only have one C++ demo in here, and the rest of it is JavaScript and XAML. So you'll have to bear with me because I prefer C++, so I struggle with the other things, but we'll get there. Anyway, as I say, we will support all of those things, right? It's a matter of interest. Is there anybody else here who's got languages that we're not supporting, that they use day to day? F# or anything? Right? Okay, fair enough. What languages do you?
No, this is one thing that I was quite.
Oh, yeah. Well, yeah. No, well, that's of course not a language, right? And so that's Cocoa and what's it? Objective-C. Objective-C is very similar to C++-ish. Yeah, no, yeah. I put those under C++, to be honest, right? But yeah, I take your point. So that's what we will support today, and that's how it works today. Now, the one other thing that's not on these slides is DirectX. We will also support DirectX for games programming, and it works slightly different from the others. It's not on the slide, so I'll mention it now so I don't forget. But as I say, we do support DirectX. We only support it from C++. It is for games programming. That pinball game you saw was a DirectX game, right? Okay, so that's how things work today. What are we going to do going forwards? First of all, we have this thing now we call the WinRT. And WinRT is a whole programming model. It actually takes all the low-level functionality you need, communication, graphics, and devices, and so on and so forth, and wraps those up and makes sure that you can only use those in the right way. So it actually provides brokers so that you can't go and access things you shouldn't be accessing. It provides an asynchronous execution model, a whole range of other things which wrap up the standard lower level type functionality that you're going to use, right? And of course, as I've already said, going forwards, we support the three languages, C, C++, C#, VB, and JavaScript going forwards, and then HTML5, CSS, and XAML on top of those. So those are the UI languages. That's how you go and build a Metro-style application. So some of today I will be doing it in the demos in JavaScript. Some of it I will be doing in .NET. C#, and XAML. So I'll be using both going forwards. As I say, my personal area of expertise is C++, so I don't get to do a lot of C++ programming. However, the first application I show is actually C++, so let me just do a very simple hello world just to go and have a look at some code in here. All right, so first of all, let me just fire up. This is Visual Studio 11. Looks slightly different. This talk is mainly about Metro, but I will talk about the tools as well. As developers, we're very interested in what's happening with tools. And there's a couple of things that we're doing with the tools. First of all, obviously, we're trying to support the APIs and the Metro styles, and I'll show you during the day how that's done in Visual Studio 11. This is actually the Express edition, so this is the free edition. But we also are actually bringing together Expression Blend and Visual Studio as well. And we're trying to integrate them much more closely so you get a better design experience in Visual Studio and you get a better programming experience in Expression Blend. Hands up who here is designers rather than developers? Okay. I'm not a designer. I will show a little bit about Blend, and I'll show you some of the things we're doing with Blend. But in general, I'm not going to be drilling into that in any great degree. But the principles behind this is we're bringing in together some of the design elements, as I say, into Visual Studio from Blend, and the programming elements the other ways around. So, for instance, in here, this is actually C++. This isn't C++. This is actually XAML. But this is XAML running against C++ underneath. So you can see here, this is very standard XAML running. And up on top here, we have a design surface now we can go and have a look at. And we can, in the design surface itself, let me just zoom in a little bit so we can see it a bit better. You can see I've got a button, which I've just put up as a button. So all that's happening here is I've just got a click me button down on the bottom here. And because I have this design surface now built in, I can actually go and take this, for instance, I can move this around, and you can see automatically it updates the XAML underneath. So it does start to give you quite a lot of design inside, well, certainly for me, at my level, it starts to give me some design elements inside Visual Studio itself. It also allows me to go and actually have a look at the platform side of things. So one of the things that's slightly different, I guess, about Windows is that we do support a wide range of devices. Right? We're not just on a single device or 2 or 3 devices. You know, we don't have 1, 2, and 3, and that's it. We actually have a wide range of OEMs providing lots of different screen sizes, lots of different screen formats, lots of different dots per inch, and so on and so forth. So we actually have to support all those. And indeed, as we get into the tablet space, we also have to support applications being transitioning from one side to another. So we need to do that, we need to give you assistance in doing that. It's actually quite a lot of work to make sure that your application works no matter what the format is, no matter what the screen size is, and so on and so forth. So we actually provide some of that. We provide some of that at runtime. We also provide some of that at design time. So for instance, in here, I can say what views I want to actually have. Okay, so I have a little platform button here which allows me to go and have a look at the particular views. I can say whether I want to see the Chrome, i.e. whether I want just the outside or I want to pretend there's a box, a real sort of PC format around the outside, like a barrier. I can say what size display I'm using, right? And I can go and select a different size display, a different sort of DPI, and I can see what that actually looks like in this little viewer here. And then also I can go and actually have a look in this document outline, and I can go and have a look at a particular element within here, okay, and I can have a look at the design of that. So you can have a look at the button. Obviously, this is very simple. It's just a button. But I can drill down into it if there was more in it than there is. So that gives you an idea. These are the sort of facilities we're starting to provide. We provide for everybody. Clearly, in the C++ space, this is sort of pretty new, especially the support for XAML. Let me just go and show you what happens. Obviously, when you click the button, we go to the event handler. My machine might have gone to sleep. Okay, and here's the event handler, and as you would expect, it just throws up a hello world and then actually shows it. Now, I just want to show one thing in here, and you can see this is a very standard C++ syntax, right? If you're a C++ programmer, this looks very familiar, standard syntax. We've now got this Windows as an API call. One of the things I will show, as I say, down here is this show async. And show async is different insofar as one of the key things about Metro is everything should be async. If you're going to take more than 50 milliseconds doing something, so if you're accessing the internet, a file system, a device, even the screen, you should always do it in asynchronous mode. That means that the processor can go back to using the UI thread, processing the UI thread, which gives you that very flexible and fast experience. So what you find is that whereas in standard Windows, it's very easy to have a program that jams the thread, and you start to see a jerky experience. The application starts to be rather jerky. That in Metro, because the application is always letting go of the thread, then you don't have that jerky experience. You get that very fast and fluid. So actually, to provide that very fluid motion, we actually need to make sure that everybody's applications adhere to providing asynchronous support. So we build that in. Anyway, that's pretty much it. So let me just go and run this. And it's a standard hello world application. Go and create it. Standard C++, it brings in all the headers and so on and so forth, just as you would expect. Go and creates the little application. And then it drops it in, fires up Metro, fires up the application in Metro, and it's all built on top of a Windows RT. It's always remarkable how slow the machine goes after you've been not using it for a while, especially with PowerPoint on it. Okay, so say standard hello world. You click on the little click me button, and it comes up with hello world. So, a very simple little app. It just gives you an idea of what it looks like from Visual Studio. It gives you a quick idea of the sort of things we're doing in Visual Studio, and as I say, what we're doing in order to provide support in terms of XAML support for C++ programs, right? So what do we see in this? I talked about this. WinRT is all about being asynchronous. It's very, very important that you build your application in an asynchronous manner. The APIs provide a rich access to the device underneath, so you can't really see that in Hello World, but we can. And then the APIs feel very natural in whatever language you're writing. This was C++. Oops. Actually, that was the wrong part of the slide. Let me just go back up a couple. This is same sort of thing, but I was going to say we didn't see any richness there, right? Because it was only using the base machine, right? So what we saw there, the APIs are all native. XAML use some C++, that's better. Portable C++ code. When I say portable, I'm talking, the base logic is portable, clearly, and if you're doing UI, that's less portable. We'd expect you to use Metro UI for that. So what do the WinRT APIs look like? What do they look at? What do they cover, and what can you go and use? We have a set of fundamental APIs at the bottom: application services, threading to do the asynchronous side of things, memory management, authentication, all the standard stuff you expect down at the bottom. We have a set of media APIs, playback capture, and I'll be showing some of these later on. One of the key things about this is we actually do provide a complete pipeline. We provide a complete media pipeline, so you can plug different elements in. You can decide you want to have a different decoder, for instance, and plug in a different decoder. You can decide you want a different source and actually use the same elements as part of the whole pipeline. So we are providing all of those things as part of the media set of APIs. Clearly, we support all the standard devices as well, NFC, all the GPS type sensors, location sensors. The things like cameras, accelerometers, and we do quite a lot of work actually to provide to pull those sensor information together to provide additional information from a number of sensors tied together, and I'll talk about that in more detail. We provide communications and data support, obviously things like XML and networking at the bottom end. Obviously, all the internet support that you'd expect to have is in there, web support and cloud storage support. We also support the whole area of notifications. So it's important that when we talked about the UI, we say, as part of the UI, we're going to be starting to put up additional information so people can use the tiles to be notified of particular events, which clearly mean we have to provide a complete notification subsystem underneath. And we do that, and we'll be talking about that in a little bit more detail. The whole area of contracts, and again, we'll be talking about that in more detail as well. So there's a whole wide area of communications and data support in the APIs. And then finally, the APIs itself, HTML5 and XAML, obviously as the UI, and the DirectText I've talked about. We also support a number of different controls, which provide the things like built-in data binding and templates. We support the tiling that you showed earlier, and you can build those very, very simply. As a matter of principle, what we've done is we've built into Visual Studio a ton of support. So if you want to go and build the sort of applications using the Metro type tiles and the Metro type formats and that sort of thing, that's all built into the tool set. So if you just pick up the standard templates, it's very, very easy to go and build an application. And in fact, that's what you'll be doing in the hands-on lab. You'll be going and building that application I showed very briefly earlier, which is the cookbook application. And you'll see that if you use the standard templates to go and do that, it's actually very, very simple, and it provides a lot of the sort of support that will be extremely difficult and a lot of work if you had to write it yourself. Having said that, you can, of course, do it yourself. You can go and write your own animation libraries. You can write whatever you like. In fact, you can actually go and have a look inside our libraries, the JavaScript libraries, for instance. You can go and have a look inside of those and see how we've done it and go and make some modifications. I will just have one little caveat on that one. If you go off and start to do stuff like that, that's where you're likely to get into territory where there may be some unforeseen things that happen, right? So I've been talking to a number of people and said, oh, well, we built our own application, we don't use the templates, we're doing this, that, and the other, and this happens, and we weren't really expecting that. So, and that, the further you get away from the standard template and setup, then, the more strange things may happen. You have to remember at the moment we're at a consumer preview release. This is still a very early release, so some things don't work. And one thing I will say, actually, is if you use the applications, those aren't even really consumer preview release version applications, right? So the applications themselves have been written more as examples than as solid applications that you would use every day to day. So to give you an example, for instance, I happen to notice on the weather application, there's a back button on the top, on the highest level, which there shouldn't be. So even those applications don't necessarily follow all the guidelines. So don't go and look at an application and say, oh, it does this, so therefore that's how I should do it. No. Some of those applications have not been written quite correctly, and some of those applications have been written not using the templates, and some of those applications have some bugs in them as well, because they are very much example applications. So, as I say, don't judge the quality of the underlying platform by the example applications that sit on top of it. Some of those applications, as you can probably tell, really annoy me. So that's why I'm just saying that. Okay, so talked a little bit about the APIs. We'll be using these APIs later on, but as I say, wherever possible, we built this all into Visual Studio, so you don't have to worry too much, and all the standard type of activities that you need to do to build the applications is created for you. So let's go and have a look at the same Hello World type application in C#, right? So we've done a little bit of C++, let's go and have a look at the C# one. And so this is the C# application. The machine just fire up. And you can see it's very similar at the XAML level. Okay, same sort of button click. We've got the same facilities. This is the other thing. Wherever possible, we're trying to provide the same facilities, the same toolboxes, the same support across all the languages. Now, that's not always true. So in some places, because obviously things like JavaScript are interpretive, so it's easier to do some things in JavaScript because it's at runtime than it is in C# or C++. But in general, we're trying to provide the same functionality across all three in the tools. So, you have the same things I showed earlier in terms of design surface and so on and so forth. The XAML, of course, is exactly the same as you would expect. And we go across and we go into the application itself, into the code, the C#, and you can see here, this is a very standard piece of C# for the C# programmers. It looks exactly the same sort of format that you would expect. Now, I've actually not just put up Hello World because that was rather boring. So this one actually does a little bit more than just Hello World, and actually does some work with the file system. So what this actually does is, rather than put up Hello World as we did last time, we actually say, do you want to open a file here? We look for yes or no, and then of course we do async as always. So we're waiting. So we're doing an await with an async in here. That's the show async. And the await keyword actually is what we use to wait for the response to come back. And then if we get a yes back, what we actually do is we go and pick up a picture. So what this application does is says, do you want to go and get a picture from the file system? And if you say yes, it actually then goes and uses this WinRT picker system, file picker, which goes away, and it looks through the files. Okay, and then if you pick a particular file, you can see it's here, it's waiting for you to pick the file. And if you pick the file, then it goes and picks up the data and puts it up on the screen in a specific format. So let's go and run this and have a look at what it does. And the key thing about this is, because this is a WinRT call, this picker is a WinRT call, is actually it will pick up data from anywhere that the operating system knows about. So you clearly can pick up data from your own file system, as you would expect. So let me just click on this. And it says, do you want to open file? I say yes. And now what it does is it goes, and this is used in the OS, right? And it can go up, I can go and obviously have a look at my file system. This is things in my file system. Or I can go and look somewhere else in the file system. I can actually go off onto the internet and look in there as well. Just go back into the pictures. So I could actually go and pick something up from the internet, from the cloud, from an area like Facebook. I'm actually just going to pick up, I don't know, this picture here, open, okay, and it just picks it up, and that opens it in my application. So it's very few lines of code, but allow me to go and use anything that the file system knows about. With just those very few lines of code, it allows me to pick up a file from anywhere that the OS knows about. Let's go back and read the slide deck correctly this time. So we saw the APIs are native. They look like native. They're actually not native. I don't particularly agree with that. Let me just show you. Actually, what actually does happen in real life under here is if you have a look at what's going on, you'll see that actually up at the top, you can see it's actually going and pulling up .NET type assemblies in here, okay? And this actually is running .NET 4.5. Now, we're not advertising the fact, but that's actually how it works, right? So what we're doing is we actually take your code and we transmit it through a WinRT to a .NET CLR, which then goes and runs. And so it's actually not running native, but WinRT gets you as close as possible to .NET. So there's very little overhead associated with it. Okay. I've gone back to the wrong place again. Because the APIs are very generic, you're not just talking about a specific file system, for instance, you're talking about any data. It allows you to then have very rich access to anything that the OS knows about, be it the OS part of the base OS or part of services. And the APIs are very similar. They look the same, but they're natural for the particular language you're talking in. So that's what we've seen in those two, and it's very similar in JavaScript as well. I'm not going to write a hello world in Java, put up hello world in JavaScript. So how does this actually work? What we actually do is we create these things called projections. So when you go and write your application, a WinRT puts a projection on the front of that application, and then uses those projections to build a Windows runtime object over on the left-hand side, or component. These actually look just like components, right? And so the components themselves are written in C++, C# or VB. We actually then keep a WinMD file, Windows metadata file, and that has all the information the projections need to know in order to start that particular application up and connect the application either to the base operating system or to other things as well. So this Windows metadata file is actually very key. It holds all the information you need in order to actually use these applications. Now, of course, this means you can go and build an application in, say, C++, and then call it from C#, or you can build an application in C# and go and call it from VB, or from HTML and JavaScript, right? So it actually gives you a lot of flexibility to build a sort of complete component model, and use whatever language is most appropriate for the particular part of the application you're building. So that's given a quick run through Windows RT, what the APIs look like, and how we actually build those APIs. I think the important thing to take away from this one is these projections are actually very, very thin. So it looks as though you're actually running native, right? It's actually very, very close to the hardware. There's hardly anything in here when you make these calls, so therefore there's a minimum amount of overhead associated. And the machine runs as fast as possible. Your application runs as fast as possible. In terms of the user experience, and I'll be talking about this in the next session in a lot more detail, is okay, so how do we build these applications? How do we make them look the way that we saw earlier on? we believe it's actually very important that people have a similar sort of experience when they see applications. In particular with the Metro design, where we're using the outsides of the screen for control and things like that, we believe that if people start to put their own Chrome on, it will become very confusing. Right? So we would like, wherever possible, for people to build applications that look similar and that the applications provide functionality as rather than you spend all your time building Chrome, and then, by the way, that looks different from everybody else's Chrome. We'd prefer it if everybody's applications look similar, because it makes it much easier for the user to use an application which has a sort of fairly standard look and feel to it. So we call that Metro-style design, and it encompasses a number of different areas. This whole area of fast and fluid. Key to that is asynchronicity, of course. Snap and scale. So as you turn the screen, your application should go to the right format as you move the screen around. If you have the screen, if you use half the screen or a third of the screen or whatever it is, when you snap, again the application reformats the data in the correct way. We provide the tools and the formats for that and the templates. But again, we'd like you to use them so that when somebody turns the tablet around, your application still looks good. Using the contracts, share and search, make sure that you support those as well, so people can take data from your application, or you can pick up data from other people's application. Have a great tile. The tile is the entry point into your application. The better the tile looks and the more information the tile provides, then the more likely people are to use the application. It's obviously got to be connected back into the internet, be alive, so you use notifications wherever appropriate, toasts, so you get more and more information back. You can roam to the cloud. This is an important area as well. We believe people will be taking their tablet, they'll be going on, reading a book on their tablet or something like that. They'll be coming back, and then maybe at home they want to be able to look at something that do the same thing on their PC. It's important that all the information in the application moves from one machine to another machine automatically. We provide a lot of that functionality as part of WinRT, so that if you store the information that's required, that you need in order to be able to move the state across machines, then we will actually do the roaming automatically. And there's this thing called the Microsoft ID, which used to be called the Live ID. And the Microsoft ID actually has a set of data associated with it, and in that information is a set of state information. And if you store state information as part of your asynchronous calls, and we'll talk about this in more detail, that will automatically get roamed up into the cloud as part of this Microsoft ID, back onto the other machines, and so somebody picks up your application on another machine, they will have exactly the same experience. And then the whole Metro principles in terms of design. So that's what we're hoping that people will build applications to look like. We believe that if people do that, it's to everybody's advantage. The more people who have applications look very similar, then it means that the user experience becomes much more easy for people to get used to, and they don't have to relearn every single application. Okay, so that's talked about the UI side of things. I've got the next session. We'll drill into that in a lot more detail. The other thing I want to talk about briefly is the whole store. Clearly, we have to have the store, but we also need an application execution environment that's associated with that store as well. And let me just go and show you the store very briefly. So this is the Windows Store. And again, usual, fast and fluid, very simple. Now, we understand that one of the key things about Store, especially when you have very large numbers of applications, is discoverability. So we provide all the sort of standard things you'd expect. So we have multiple categories. We have games, we have music and videos, books and references. So we have a number of different categories. And then in each category, we have like the top 3 ones. We also believe this whole spotlighting area is very important. Clearly, if your application shows up in these top-end spotlights, then more people are going to buy them. So, the whole area of editorials is very important. This is an editorial we'll provide. And obviously then it comes up with different applications as part of that editorial. The applications themselves, obviously, you can say whatever's picked for you, what new releases are, what's the highest rated, and so on and so forth. So all this information comes back. But one of the key things here, I think, is probably that it's very important that if you go and pick a particular application, we give the maximum amount of information about that particular application. So this is cut the rope. I've already installed this particular application. But you can see we provide things like the ratings that people have given for this particular application, description of the application, some details about it. This is an important one. You can see here, I talked earlier on about making sure that the application can only use those things that people expect. And you can see here in the store, what the application is going to be able to use. And when the user actually loads this down, it will say, am I allowed to use the internet connection, right? So it also says, obviously, what the processes are on there. One of the things that's very important about this is, of course, that all these applications, you recompile the application for both Intel and ARM type processors, so it will run on either architecture. All of WinRT will run on both processor architectures. So we will support tablets using ARM processors, tablets using Intel processors as well. And then, of course, we have areas like reviews. I'm surprised nobody's written a review on that, but you can see the number of ratings and so on and so forth for the particular application. So the store provides the user experience and user interface, and we'll talk in more detail about how it works. But I just wanted to show you what it looked like. Okay. How does it actually work underneath? Talked a little bit about this. Designed for discovery. It's unprecedented reach. It's going to be on every copy of Windows. There's, I say, Windows 7 sold 500 million copies. So we're going to be seeing a very large number of places where the store's going to reach. We have a wide range of business models. One of my jobs, two and a half, maybe 3 years ago, I actually worked on the store strategy for Microsoft. It's actually very complex, the whole area of stores. It looks very simple when you see a store built like that, but it's actually a very complex area. And it's actually complex in two dimensions. First dimension is actually the sort of business model that people want to use. And so, for instance, we have free is an obvious one. Then you have things like trials, try to buy, rental types models. You have advertising models, built-in advertising. You have in-application purchasing, in-application upgrades. There's a whole wide range. So actually, we need a store model which supports all those two, which indeed this particular store model does. I think there's probably some more models out there that people have still got to come up with in terms of what different ways of selling applications. And I think there are probably some new ideas in that space that have still got to come through. And then finally, the economics. It's important that the store provides you as developers the best economic model. So, for instance, we use a standard 70% for less than $25,000. But if you make more than that, we take a smaller cut. So we're trying to make sure that you have the best return from our store. And indeed, if you do things like your own commerce, so if you actually have you actually deliver through our store and distribute through our store, but then actually you do charging through your own system, then that's free. We won't charge for that. It looks like a free application to us. So we're actually only charging when we're actually having to do the billing ourselves. Billing is a big problem. In fact, this is the second dimension of the problem. One is the business model, and the other is the billing side of things. And you'd be amazed how difficult it is to do billing and payment. And I know here in the Gulf, we provide you the ability to download in the store, but from a developer point of view, unfortunately, at the moment, we don't support direct payment to you. You have to go through a third party at the moment. We actually support quite a large number of countries, and that will increase over time. But the real issue in terms of supporting different countries is actually not really a technical issue. It's a business issue, because we actually have to take taxes, and we have to deal with individual countries, and each individual country has different tax laws that are associated with that country, and the country themselves have, how do I put this, have a different attitude towards where and how people should earn money. That's probably the safest way of putting it. So different countries, you know, they may want to control where the money is paid and so on and so forth, in particular for tax purposes, right? I think every tax organisation in the world seems to want a lot of money. As you can tell from my accent, I've come from England. I now live in the US, so I actually end up paying tax in both places, which really annoys me and greatly upsets me. But it doesn't seem to be any way of avoiding, not avoiding, whatever, not having to pay tax in more than one country. And indeed, this is really one of the major problems with the whole area of billing and payment. Over time, we hope to make it better. We hope to support more countries. And as I say, we hope to improve the whole billing and tax information. But it really does depend a lot on working with local banks and local governments around what their taxation systems are and things like that. So, you know, I wish we could do better. We could support everybody day one. We're not there yet, but we're working on it. Okay. So the store itself actually provides you the application. The next thing, of course, you have to do is you have to take this application and download it and execute it on the machine itself. And this is an important point, because when the application is then executing, you need to have it in an environment where, as I say, it's secure. You've got guaranteed implementation and so on and so forth. So this is actually how it works on WinRT and in Metro. You go up to the Windows Store on the left-hand side. You select your application and say you want to install it. It actually goes up to the back end. The Windows Store back end gets the package, and I'll talk a bit more detail about the package in a minute. Takes the package from the store back end, in the cloud, drops it onto the machine. The machine has this thing called the package manager, and the package manager has an execution engine, goes through it, unpacks the package, checks what extensions it needs to go and use as part of that, and then stores it out into a single instance store and registers the information about that store with these WinMD files. This means you only have to load the application once. So if you have multiple users on a machine, then you only install the application once, and the single instance store can be used by any of the users on that machine. It does actually mean that the individual users have to pay, by the way. So just because there's a single instance doesn't mean to say you only get paid once, right? There's multiple. If more than one, most of the licensing is per user. So if you've got multiple users even on a single machine, then they both have to pay. But they actually may only be using a single instance of the application itself. Okay, so that's actually how you load up the application itself. As I say, this application comes down as part of a package. And so what's in the package? The package has obviously your files and assets, right? So all the things you'd expect to have that you've generated as part of your application. That ties that up with this manifest file. And the manifest file is actually one of those WinMD files, and I'll show you what that actually looks like in a minute. It's an XML file. We then have a block map so that when you download the file itself, we know what blocks you've downloaded. You know, if the thing doesn't load the whole application, then we can do a rollback because we have the block maps when we're doing the load. We've signed the whole thing to make sure, obviously, that it's a known good application, and then it's all zipped up as a zip file, right? And that's what the Apex package looks like. So as it says there, signature ensures that it's a valid package, and the block map has the hashes so we can make sure that the application execution engine only pulls out the right parts. The manifest in there, it declares exactly what the application is going to do. And I showed you in the store, it says this is going to use the internet. You as developers can say exactly what your application is going to do, what it's going to use in the machine, whether it's going to use a file, devices, networks, and so on and so forth, and what contracts you're going to support. and it builds that into this application manifest. Visual Studio provides an editor to do that, to go and control that. And so let's go and have a quick look at that. So if we go and have a look at this, this is our manifest package here. If we go and have a look at this, okay, you can see here, this is the Visual Studio editor to set up exactly what it is you're going to put into the manifest and send to Microsoft. So obviously you have the name. You also have what particular rotations you're actually going to support. You say what particular tiles you're going to provide. This is where you actually put in what tiles are going to be used. So you put those in there as well. You know, what notifications you're going to use. You can see there's a whole load of information that goes as part of this. Okay, and then you have the capabilities itself, which is the thing I was talking about on the previous slide. You just tick what it is your application is going to do. Okay, so if you're going to use the microphone, or you're going to use the pictures, or you know, proximity detection, or any of those things, you click on here. What then happens is when you submit the application to Microsoft, we check through to make sure that it is reasonable that you're detecting location, because it's part of your application. If it's a word processor, then there's not really any reason why you should be detecting where somebody is. So, we obviously check that the capabilities are appropriate, and then we'd actually then load that up as part of the package. The package gets downloaded, and the user knows that when they load up, that it's going to be using your camera or something like that, and gives authorization for you to be able to do that. And we'll see that actually happening later on. Okay, so once we have the application and it's loaded up and we've made sure everything's correct, actually then how do we make sure that the application runs inside the machine? What does it do in terms of asynchronous? You saw that the applications are in general full screen, and when they're on the screen and they're full screen, then they pretty much have all the process power going to them, right? So obviously there's a whole lot of background threads that the OS has, but in general one application runs at a time. So once you're not on the screen, then you go into this suspended state. So you start off and you're running. Somebody clicks on some other application, you suspend, you go off. You saw them on the left-hand side in my user demonstration. Those were suspended applications, right? And they sit in this suspended application state. You get warning before you go into the suspended state, so you can save any state information you need. And you have like 5 milliseconds in order to save that information, and then you become suspended. You still obviously exist in memory, but you're not actually using any processing power. The processing power is going to the executing application. If somebody then pulls that back in again, then it resumes, the state is reinstantiated, the application continues to run. So that's pretty much what happens. You have a number of suspended applications. The only time when your application gets shut down, other than if you go and do it yourself, is when you get low on resources inside the machine. And then what happens is the application gets paged out effectively and gets terminated. It's important because you as an application developer need to make sure that when you go into the suspended state, you store your state information because you don't get any warning if you get terminated. And we'll talk about this in some detail tomorrow, how you can store your state information. Hang on, let me just go back 1 second. The only difference to this is actually applications that use audio, because clearly if you have a music playing application, you want it to continue to play music in the background, and so music playing applications actually have their own thread that's running that the music plays on, the audio plays on, even though they may be in a suspended state. So it does still work for audio, but everything that uses the screen actually goes into the suspended application state. This is actually quite a different model, and this is why, from standard Windows, and this is why it's important that you, wherever possible, make your application asynchronous, because we are going to suspend the application if necessary. It does mean that you get a much better performance characteristic for the particular applications that's running on the screen, It also means that you don't have all those background tasks running because they actually get paged out. I actually talk here about suspended, and as if when you go into the asynchronous or waited state, that doesn't happen in Windows today. Of course, it actually does. The difference is that we actually define when you're going to go into when we're going to let go of that particular thread by using that asynchronous keyword. Whereas in Windows, very often the thread blocks, and the operating system itself then has to take the thread back, the processing thread back, and that can take some time, which is why in standard Windows, you may get a delay on it, whereas using this asynchronous method, you don't get a delay. So I will be talking as though standard Windows blocks completely. Clearly it doesn't. I understand that, but just for simplicity, I will be talking about Windows as though it blocks and Metro as though it doesn't. But as I say, it's actually not quite correct. So we have the processes. We know how they're actually going to execute and where they're going to execute. We also have to make sure that they're isolated. So RT does effectively provide a sandboxing mechanism. Each process runs in its own context, in its own sandbox. It can obviously access its own local data. And as I've already talked about, it's roaming data and temporary data and things like that. But basically, those are all held in that local context. And if it tries and goes outside that context to access things inside the file system, for instance, then it has to go through this broker to make sure it can do that. So this is something that's different from Windows today. Today in Windows, you can go and access pretty much anything anywhere. We won't allow that in Metro. You have to go through, if you're going to go and access a camera, or you're going to go and access the file system, then you need to go to WinRT. WinRT provides this broker system, and the broker actually goes and says, okay, do you have permission to go and use the file system from the user? And if you have, then it will let you continue. Right? So there is a difference there. We are providing this mechanism to make sure that applications can't go and change things in the machine without the users knowing. And obviously, then things like file system, devices, and so on and so forth, all those things you then access through that set of brokers. There are a number of direct APIs which access elements of the OS itself, but as I say, things in particular like files. If you want to go and decide you're going to go and trash across a bunch of files somewhere, you will not be allowed to do that without the user's explicit permission. The only way that one process can talk to another is through these contracts. And this model is this picture is slightly misleading because, of course, the contracts actually go to the OS itself, and the OS has this concept of contracts. And so if your process, your application goes and accesses, for instance, the share contract, okay, in the OS, then that share contract then comes back up into the other process, and the other process then can use that share. So the only way two applications can talk through one another is through one of these contracts that's been provided by WinRT. It allows you to do sharing, it allows you to do searching, that sort of thing. There's a couple of other contracts as well, and I'll talk about those in some more detail. But the key thing to take away from this is that the application is sandboxed. It does you are allowed to go and use anything in the machine you like, but you have to tell the user, and the user has to give you permission before you can go and do that. And I talked a little bit about roaming. Your application can go and use local data, keep its state information locally, and then the data syncs up to the user's Microsoft account, goes backwards and forwards, and so that makes it very easy for the user to roam the information wherever they need to go. Now, this is clearly not for videos, right? I mean, this is for state information about your application and maybe a small amount of data. If you want to store videos or audio files or anything very large or pictures, then you should store that through some sort of cloud storage like SkyDrive. SkyDrive is providing more and more functionality to support these types of environments. But we will roam small amounts of data. And it comes back to that point I made a little earlier about if you go into suspended state, you should make sure that you flush any state information in your application out into the local storage. Windows will then make sure that gets synced up in terms of up into the cloud. So, if somebody's using their application, again, a reader application, they've got to a particular page, okay? They click away from your reader to go and look at email. You should make sure that you store the page number into the local storage. Windows will then replicate that up into the cloud. If they then go onto a PC somewhere else, that information will come back down into your application on another machine, and they will get to the same page number. Okay, but you should make sure that you make sure you flush that state information into the local storage for Windows to be able to do the replication. So, talked a little bit about Metro from a user's perspective. What I want to say is okay, so what are we trying to provide with WinRT? What are we actually trying to provide you as developers so that your applications can provide certain capabilities, can provide a certain feeling for the users, right? And the things that we want users to feel with Metro-based applications is these three things. We want them to feel that they're confident that the application's doing what they expect it to do. That the application's not going to stop the machine running, it's not going to slow things down, it's not going to go and inject malware into the system. They know exactly what the application's doing. So we want them to feel confident when they download an application that it's not going to mess up their machine. We want them to feel that at least the machine is connected, so they can go from machine to machine, the data's roamed, they can access the data from wherever they want. And then finally, we're providing these very close shims, effectively, to provide as much native performance as is possible. So those are the three things we really want users to feel when they're using the runtime. Okay, that they're confident it's working very fast, and that it's connected to both their other machines and into the internet as well. So that's the idea and the concepts behind WinRT and the platform. Okay, so I'm going to go straight on now. That's given a quick overview of what we're providing as part of Metro. Now I want to talk a little bit about the design side of things, actually how you can go and design a Metro-style UI and what we expect. And I'm going to go through this very quickly because there's not many designers here. I apologize for the person who is. But I do want to give you an idea of some of the characteristics that you have to think about when you're building an application. So I'm going to go through this fairly quickly so we can get out in time for lunch. Okay. So this is how you actually go about designing a Metro-style application. And these are what we're calling the traits of an application, right? So first of all, it has a style design. So the key thing here is that we use a very standard sort of look and feel. We use a standard typography, standard coloring, standard block size, and so on and so forth. So it looks like a Metro application. People associate it as a Metro application. Talked already about some of the other things in here. Fast and fluid, snap and scale. When you turn the machine around, it does what you'd expect. Uses the contracts wherever applicable. Has a good tile, connected and alive, roaming, and the principles. So let's go and have a look at the design side of things. First of all, and I talked a little bit about this, content before Chrome. Especially on smaller machines, it's really important that people have the maximum amount of data that they can look at. They actually have the maximum amount of information rather than a whole load of UIs and Chrome and search buttons and so on and so forth. We did a lot of user testing, and when we asked people to draw what Windows looked like, this is what they drew. This is what they think of Windows. And you can see this is actually not an application. This is the Chrome. This is the scroll bars and the search buttons and the maximize, minimize, and so on and so forth. They actually think of Windows as being the Chrome, not of the applications. And we want to turn that around so that people think of Windows as being the applications that are run rather than the toolbars that sit around those. So when we showed them Metro, this is what they drew. They actually drew the applications, okay, and one piece of control up at the top there. But you can see the idea here is that now they're looking at the data and the information and not the Chrome. So they're beginning to associate the applications in a different way. So the way we do that is, as I say, we promote content first. We use as much of the screen as possible, and then we take off anything that there's going to be a distraction, right? And typically, Chrome's used for these three things: layout, interactions, and navigation. So it's used to give you boundaries on the screen of where things are. It's used for people to do things like search, right? You put a search button up or something like that. And then finally, it's used to navigate into lower levels. So we need to make sure, so it would be nice, very easy and nice to say, hey, we're going to throw all the Chrome away, don't use the Chrome. But of course, it actually is used for certain things, right? So we need to come up with alternative ways of providing things like layouts, interaction, and navigation. And that's what I'm going to be talking about later on in this talk, is actually how do we do layout, how do we do navigation without a Chrome? So let's have a look at the layout first of all. Typically, again, today, in terms of layout, what people do and what most applications do is they put in lots of boxes and they get the content close together, and then they use boxes or lines to divide up content. Actually, what that does is it makes the screen very busy and very difficult to see the information underneath it. So what we would recommend is that you leave space around the content and take away the frames. And it's actually then the space that gives you the context of where the information is. And you get this group and organization, but using space and not by using lines. It makes the screen a lot easier to see. So let's have a look. What does that actually mean? Here's a typical application. It's an RSS reader application. And you can see that, there's a navigation system on the left-hand side here. There's some feeds. There's the information about the feeds in the middle. And the actual content is the little bit down here on the right-hand side. Well, this works okay if you've got a very large screen. But of course, on a small screen or on a small tablet, you're going to end up with pretty well everything being navigation and Chrome and very little actual content. And it's important that people have more content rather than less. So how can we go and provide the same functionality but without providing all these other bars? You can see up at the top here, we have a search pane, we have sets of settings, and so on and so forth. So we need to provide all that functionality, but at the same time, give the maximum amount of screen space to the application and the data. So the first thing you can do is actually just taking out the lines. If you just take out the lines and use space and color to divide up the screen, you actually get exactly the same information here. But now what you've done is actually, by using the space to divide it up, you still understand what everything is, but you've actually made the screen a lot less cluttered and busy. And people can find information much more easily. So this is the first sort of thing that we would recommend you do. And then you can use topography as well to provide structure, hierarchy, levels. You can use the sizes and weights and colors to show what's important and what's not important. And we provide all those as part of a standard style sheet so that it's all automatically generated for you. So these are the standard sizes and styles that we would recommend and that come as part of the templates that I'll be showing you later on. And here's exactly the same information, but now we've taken away the navigation and we've taken away a lot of the lines, and we've gone back down to providing the content itself. And you can see now we're providing a lot more content and a lot more information, and the screen's giving the end user a lot more value without all those navigation things. We've obviously taken off some search buttons, and I'll talk about those in a minute. And we've also taken off the navigation system, and I'll talk about that as well in a minute, and how you actually can navigate. But it gives you an idea if you just use topography to say what's important. You can see up at the top, we have a particular type fonts which says, okay, this is the top level, and then use smaller and smaller type fonts to say what's the highest level and what's the lower level. So we're using topography to give information about the structure of the data. And here you go, and you take the same information and you structure it side by side, and use a different background. And again, we're now getting a much more modern look and feel to the whole application. In terms of layout, if you let the content flow across the whole screen, and you actually go off the screen wherever necessary, because we allow you to be able to pan on the single axis, so people understand that they scroll backwards and forwards on that single axis, by allowing the content to flow off on the right-hand side, you can put as much content as you want on the side, okay? That allows people then to scroll through it, and using the semantic zoom allows them to start to be able to do navigation as well, using that semantic zoom I was talking about earlier on. And as I say, that then allows a lot more navigation function, but in a different way from the standard pickers. Keep the ergonomics in mind. People are going to pan across the long edge, and obviously as you turn it around, you're going to pan in a different direction. Okay, so then you can take each individual element and you can make a graphic around that. So people now understand, they see the graphic, they click on the graphic, and they down through to the lower level information. So what we're now trying to do is we're saying, okay, how do we make this into an information hierarchy with different layers of information, so that people look at the top level and then they drill down into the lower levels in terms of navigation. And I'll show you how that works in a moment. Okay, so as I say, the silhouette, which is this standard outline, and then using this grid, okay, to give a standard layout and consistency. The Visual Studio comes with a set of templates to do this automatically. This is the nice thing about Visual Studio and the templates, and when you go into the hands-on lab, you'll build these applications using these templates. And the templates provide the standard grids that you need, the standard hierarchies, and the linkages between the hierarchies as well. So all that's provided for you, and you can build these applications very simply. It also provides things like animations, those sort of elements as well. So here you go. You start just getting the headlines themselves, okay, and you can see that you've now taken the data to roll off the side of the screen, and you can click down into any of these. What we'd suggest is that you leave these margins around the outside, and the top left-hand side is where people go back. So we always put the back button up in that top left-hand side, but you leave boundaries around the outside of the screen so that there is space in the gutters, in particular for people to be able to use the edges of the screen. One of the things that I will just quickly comment on is that most, in fact, if not all, of the tablets that are out there today are Windows 7 tablets. There's no specific Windows 8 tablets. Hands up here who's actually using a tablet as a matter of interest. Okay, so what you'll find is that the tablets today, when you try and use things like charms, sometimes it's not as easy as you would like. That's because these are Windows 7 tablets. What we're doing is we're working with the OEMs to make the edges of the screen much more sensitive. So when you flick using the charms and things like that, then the digitizers in the hardware recognize that flick, and you get a much quicker response than you do out of a Windows 7 type tablet. So we're going to see a lot of, towards the end of this year, we're going to see a lot of new hardware, a lot of new form factors. Just again, on a personal note, I've been sort of putting off buying one because I know I've seen some of the machines coming along, and it's like, oh wow, I really want to have the new machine. I don't really want a Windows 7 tablet because they're so much better in so many ways. In fact, I bought, in the end, I had to go and get something, so I got myself a little Asus W500, which, by the way, I can recommend for demos. It's a very cheap machine, and it works remarkably well for the scanning and things. But unfortunately, it's really low power. It's as I say, very low power machine. So doing demos on it is painful. Well, not doing any programming on it is painful. So I actually, in the end, have been doing it on my old machine, and it was really rather too slow to do very large Visual Studio demos on. So I actually ended up having to borrow my boss's machine, which is this one, which he unfortunately dropped. So I'm a little worried it might not work for very much longer. But I'm actually personally holding off buying a machine because, as I say, I know there's some really nice machines coming along with a lot of additional features and functions in them, and also things like better digitizers for these edge detection type activities. So, just by the by. So back on this is some examples of applications that have been built which have given this space around the outside. then use this very standard Metro type format. You can see, again, pulling up the maximum amount of data here, the maximum amount of content coming up, and then people click on the content, they touch on the button, they touch on the content to see more information. And again, we want people to understand that they interact with the content. You click on the content, and it takes you into more and more detail. And each one of these, of course, as I say, you can see here, is built so that we use the same spacing around the outside, so people understand where the data is in the middle of the screen, they understand the edges of the screen are for the sort of control functions that we know are there. And what actually, if you go and use the templates, or later on you will be going and using the templates, this is actually what the templates generate. First of all, at the top level, they have this grid function. And you can see in the previous examples what those grids look like. So you just actually end up putting your data into these templates. And in fact, it's quite interesting if you look at the code, when you go and do it, you'll see that the template code is really very standard, and there's no data in the template code, and it just pulls all the data in your case, in from files, and populates the information in the templates. So the whole thing's completely data-driven. It's actually quite nice from a programming point of view. You don't have to worry too much about what the content is, and most of the structure is given for you by the templates themselves. Obviously, this is the top level. This is a grid level at the top here with a grid. Obviously, up on the top left-hand side is your back button. Again, that's important. And then you interact with that. So let's go and have a look at the quick interactions. So that gives you an idea of the layout side of things. It also gives you an idea of how to do some of the navigation. What about the control side of things? So we saw at the top, we had the buttons for control, like search. We had things like settings and so on and so forth. And as I say, those things that you have in your application today, you should put out into the charms bar. So if it's things like settings, it should go out on the right-hand side. And we provide the functionality in the APIs, so you can go and put those, you just make the calls, and they automatically appear in the right place on the left-hand side. Similarly, if you have specific commands, home or back or pin or any of those sort of things, you can put those on the top and the bottom. And again, we provide an app bar set of controls which allow you to go and generate those automatically. And we'll be talking a lot more about the controls later on. Okay, so as I said here, you can see up on the top here, we have things like search, settings, etc., etc. Those actually then go and get put into the charms bar and disappear off the side. So now we have exactly the same thing. We can still do searching, we can still do sharing, but we don't actually have it as part of the screen itself. And here's the app bar down at the bottom. You can add more feeds, for instance, down on the app bar. You can do refresh as part of that app bar at the bottom. And of course, as the charms come up on the left-hand side, those charms are now specific for this particular application. So if you go and have a look in the settings, it will be settings for this particular application. And I showed that earlier on. Talking about what you can put in the app bar. We provide the app bar. We also provide the standard iconography to go in the app bar. And so you can see here, these are some of the things that we provide today. You can just go and use those. You call those and they will automatically come up. We have some recommendations. Global on the left, contextual on the left, global on the right. Those are the sort of recommendations. They say, please do not take how they're done today in the sample applications as being correct, because it's not. In many cases, those applications were built before, I think, this guidance. And the top app bar is for having a very large immersive views. The only application that uses the top app bar really is the IE application. If you go and have a look, I haven't seen anybody else really use that. So say use the top and bottom app bars. All the applications you'll be building will only generate the bottom app bar. We don't use the top one. So there's a few other things that we provide as part of the Metro calls. There's this whole area of flyout. So if you want to provide, collect particular information, rather than actually having a fixed box there that's all the time, for instance, if you want to add something like a new RSS feed, you have the plus to add the US RSS feed, and then you actually put a box up, a flyout box, to actually put the data in. And I showed you that very briefly. If you remember when we were naming, when we had the semantic zoom, and I was naming one of the blocks, it actually came up with a little box, which was a flyout box, where I could go and type in the new name. So again, don't have the space always used, don't have the box on the screen all the time for people to type information in if they're only going to do it once a day, or, you know, it's just wasting space. You just do that as a flyout, it comes up whenever you need it, and it's normally propagated by some action on the app bar at the bottom. And again, obviously you can do things like warnings and stuff like that as well that come up. Errors, whenever possible. If you have errors, they should always come up in line. And here's some examples of that. Again, you know, it comes up straight away in line where the people are actually looking at. So let's talk a bit more detail about navigation. Navigation is quite a complex topic in lots of ways. You saw in the original feed, we had the bar, the navigation bar, the nav bar, and you could click down into that nav bar. In general, most applications don't go that far down. In fact, most users in general don't navigate that far down. If they're navigating that far down, there's probably a bit of a mistake somewhere in the way the application's built itself. Users, if you're navigating into a long way down into the system, tend to get lost. So what we do is we provide a navigation system which only goes a certain length of down, and then after that we don't really go much further. But the way we provide that is, again, by clicking on the content itself, then that goes down into multiple sub-levels. Okay, so we have this thing we call hub and spoke for an information hierarchy. So you have, you know, the single entry page, the hub at the top, and then that goes down into a number of spokes. And then you can use semantic zoom to actually change the information. So when people shrink the content down, we can provide high-level information as part of that, okay? So this is what that actually looks like. You have this top-level hub. So this is a travel site, for instance. It has a top-level hub, and it has things like destinations, deals, trips, and so on and so forth. And then as you click onto that, you go into the spokes information, and then finally you go into the individual detail information at each level. So we're effectively providing a three-layer hierarchy here, okay? Obviously, you can build deeper hierarchies than that using the same model. Again, as I say, in general, people get lost if you have too deep sets of hierarchies in your information model. We feel this is a good balance between providing a simple navigational model, an obvious navigation model against the complexities of providing a much more deep and rich navigational model. If you're an enterprise developer, then you may well find you need to provide deeper depths of hierarchy than this. If you're deep inside some large enterprise program, then you may need to go further down than that, and in which case this sort of changes and is not so valid. As a matter of interest, how many people here are enterprise developers of some sort, you know, working for a bank or something like that? Okay, thank you. As I say, so these models are very much for consumer, okay, this sort of information model. Just again, on a personal note, of course, there are actually three levels of, three dimensions to hierarchy, to navigation. There's a two-dimensional, there's the three-dimensional, which we're used to, and then we have full network navigation. Very few people can actually navigate with a full network. It's very difficult to do that. And so normally we end up with one of the lesser models for information management. There is always this balance between understandability of your navigational system against how valid it is for what you're trying to do. And as I say, in general, in the consumer space, it's not necessary to get that complicated. People get lost. Again, there are some applications where that's not true, especially in the enterprise space. But then you have to really start thinking about information and hierarchies and information architecture in a much more general sense if you're doing that sort of thing. This is a fairly basic model, but again, we believe for most consumers this is a model that they're quite happy with. Okay. So talked a little bit about semantic zoom. This is showing semantic zoom. You can take those hub elements, you can click them, and then you get zoom information, and you can put more contextual information on top of those semantically zoomed blocks. This is what we're going to show. I've already shown semantic zoom earlier on, so I'm not going to do that. Actually, I will just show. Have I got time? Yeah, I'm okay. Let me just show semantic zoom in this cookbook application. So this is built using those principles, right? It's very simple. Now, if I actually semantically zoom this, there you go. You can see when I semantically zoom, what I do is I can actually combine a number of the different elements, and then I can put additional information up. So I have 6 Chinese recipes, 5 French recipes, and so on and so forth. And then I can zoom back out again and look at the individual elements within that. So that's where you can start using this whole area of semantic zooms. Semantic zoom because you're zooming in and out, but you're also providing additional information when you do that. So obviously it's providing a better experience, more information, or different sorts of information when you do that. Okay, and as I say here, design a zoom out view to show richer meta information on your groups, and try to fit the content. When you zoom out, try to fit the content into a smaller space. You really don't want to go a long way out if you're on a semantic zoom. And then you can arrange operations on particular groups, and I showed that. You can actually name a particular group, for instance. You can let the users name a particular group. But the scope of the content, what you're actually trying to provide, should stay the same. You shouldn't add additional information. And as it says here, it's not for navigation, right? So it shouldn't be used as an additional level of hierarchy. It should be used at each level within the hierarchy to be able to provide a different view into the information. So here we have, it's an example with produce. You have fresh fruit, you have vegetables, and you can then do, as I showed in the Contoso demo, you can actually do a zoom where you actually add up the numbers of things that are in each of those elements. So you can see where you have most information and so on and so forth. Okay, fast and fluid. This is really about asynchronous and animations. It's not perhaps particularly obvious when you're looking at it, but actually when I'm using Metro, you actually get quite a lot of animations. Let me just show you what I mean by that. Oops. So for instance, when I go like this, you'll notice as I get to the end, it bounces, yeah? Okay, that's an animation, and the animation is meant to show that you've got to the end of the information. Similarly, within a particular application, again, if you open, you'll see that if, for instance, when I open in a particular element, you'll actually see there's an animation as it comes in. So as I click on it, it shrinks, yeah, and then it moves in slightly from the left. What's happening here is we're using animation to show that information's coming in, and we're showing animation to show that you're picking things, right? So you can see when you select it because it gets smaller, yeah? You can see something's come in because it moves in from the side. So using fairly standard animations, it gives people a much better feeling for what's happening on the screen. And so we provide all those animations as standard Windows Metro calls, because actually to write animations like that is fairly complicated, obviously. But we provide all those as standard animations. So you can go and use the standard built-in controls for things like switching pages and stuff like that. And you will get all those standard animations automatically. And I'll be showing you in the controls session how you actually can go and use those controls to build those sort of animations. And again, that application, that cookbook application, you'll go and build, and you'll see when you build it, you automatically get all those animations that you saw. And this is a fairly important point. So I've been talking a lot about touch. And these are the touch elements, right? And you should design, in Metro, you should design for touch first. So, you should design for tap, swipe, slide, and so on and so forth. These are the standard activities that we expect people to do and that we have controls built in for. So if you do these things, then you will get automatic calls through into your programs to say that you've had a pinch or you've had a slide or whatever, and you can then go and do the right actions. Now, whilst you should always design for touch first, then it's important that you also support both keyboard and mouse as well. And we provide those actually so that any of these actually automatically map to keyboard and to mouse activities as well. And you, from a programming perspective in your application, you don't actually have to worry whether somebody touched it, whether they use the mouse or whether they use the keyboard. You will just see the same call come back. So we take care of all the mappings that are required as part of Metro. When you do design, you need to be aware of how people actually use a tablet. Again, those people that don't have tablets here, I'd sort of, if you're going to be doing a lot of touch work, I'd sort of recommend that you get one and actually use it in day-to-day. It's actually quite interesting how you use tablets. And in particular, the different sizes of tablets are used in different ways. So, for example, this machine is a fairly standard laptop, and it's one of these ones which tips, swivels, like so. You've probably seen them. Actually, funnily enough, this is really bad for touch, right? Because when you touch it, it bounces, which is actually not really very good. So it's good for demos, but actually is not really very good in terms of usability. Let me just go back. And so the actual usage of a tablet is actually quite interesting, and it depends on a number of things. It depends on the thickness of the device, the rigidity of the device. It also depends a lot on the size, and this doesn't really talk about that, so I'm just going to briefly talk about the importance of the device size. The size of the device depends, actually what's the scenario that the device is used in is very dependent on the device size. So most tablets today are around sort of 10-inch size, 10-inch plus, right? You find 10-inch sized tablets are really, really handy for business-type applications. So I have a 10-inch tablet. I tend to take it to meetings and things like that. I go to meetings and I do my email or I look at browsing on it because the problem with the laptop is you always have the laptop up. It's sort of, especially in a meeting, it sort of splits you off from the rest of the room. It's also really, a 10-inch tablet is really, really useful if you're trying to work with somebody. 10 or 12-inch tablet is really interesting because, so say for instance, you're a salesperson and you're trying to show something to somebody, then a biggish tablet is really useful. A very important usage that's growing in the US at the moment, for instance, is pharmaceuticals, applications for doctors. You know, if you're trying to sell something to a doctor, especially in the US, it's really expensive. And so what you do is you try and show them that. So people take tablets into doctors' offices, and then a big tablet is very useful because you sit next to the doctor, and it gives this rather very nice sales dynamic of being next to the person. So 10-inch and plus tablets are really, really good for business applications. They're actually not terribly good, in my opinion, for consumer applications. So if you're actually reading a book, for instance, you find a 10-inch tablet's a bit big. Even, no matter how light and thick it is, it's actually not very good. What you tend to do, which isn't shown in here, is you tend to hold it on just one side. Right? You don't tend to hold it both sides. And you flick with your finger to change pages if you're reading. A 10-inch tablet's a bit big for that, to be honest, because it sort of gets a bit unwieldy. So what you find is that smaller tablets, like 7- and 8-inch tablets, are actually quite useful for start doing things like book reading. So that's why, for instance, all the ebook. Hands up, who's got an ebook reader here? Okay. If again, it's worth You're both using an ebook reader because you find that actually the sort of 7-inch, 5, 6, 7-inch is actually a good size for an ebook reader, right? And so the size of the device is actually quite important for the scenario. So if you're building an application for book reading, for instance, you probably don't want to build it for two hands like this, because people actually don't hold a book with two hands, right? They actually tend to hold it with one hand and they flip. Is that how you do you use?
Yeah, actually I have the same experience. It's very difficult with 10-inch.
Yeah, yeah.
Hold it like this is a problem.
That's right. So, yeah, and these things you don't actually find out until you go and try the devices, right? You know, it's not obvious until you've tried the devices. Now, the one device I haven't tried yet, and I keep meaning to, but they're so expensive, is the Note, is the 5-inch device. So when you get down to the smaller devices, like smartphone-type devices, what you find, especially for someone like me, who's a bit on the oldish side, my eyes are not that good. So if I try and read something on a smartphone device, even a biggish smartphone, it's actually too small. And either I get the font so big I'm doing this all the time, or the font's too small for me to see, right? So it amuses me. I go into the airport and there's all these people going, you know, on their iPhones. It's like, yeah, that's not really what you're meant to be doing with an iPhone. So, you know, the size of the tablet's really, really important, and the way it's used. And that depends. So therefore, if your application, as I say, is doing something like reading or movies or TV or those sort of things, you probably don't want to be right down in the small devices, but you probably also don't want to be on the huge devices, because if you're watching a movie, something like a TV program, sometimes in the evening I watch TV. I watch the TV on my big TV. Then I go to bed, and I'm just sitting there. And I think, oh, I'll just watch the end of that program, or whatever. And then I find like a 7-inch device is really handy just to watch the end of that TV program. So it's going to be really interesting over the next 5 years. I think we're going to go through a lot of learning about usage patterns and scenarios and what different people do on different size devices. And I've certainly found that I don't actually use smartphones very much. I much prefer a very small phone because it will go in my pocket, rather than a large phone, which I can't sort of see very well. And then I have a 7-inch tablet for doing things like reading and watching TV. And then at business, I use a 10-inch tablet. So it's really interesting once you get into this whole touch space, and you get away from just specific smartphones, which we all know and understand, but get into tablet sizes. I think that how people use them becomes very interesting. And I think that one of the reasons why tablets are sort of still evolving is exactly this reason. We as developers are still trying to work out how people actually use them. So I think this is very simplistic, was the bottom line, is that for a 10-inch tablet with somebody holding it on two hands, yeah, this is probably accurate. But you know what? You really need to think about what your application is and how people are going to use it, right? When you start designing for touch. Anyway, enough of that. But as I say, I would recommend you go and try different devices and actually live with them and use them, because it's quite interesting how it works. So design for touch first. And I talked a little bit about animations on touch, so you can see. Reversible, so people can explore, obviously. That's always true anyway. Pan in the single axis. Don't let them move things around. And snap and scale. Again, actually, as people change things, turn the screen around, or people change resolution, you need to make sure your application works. We, again, provide a lot of support around that through these different view spaces. This is the minimum view space, 1024 by 768. We have the widescreen, 1366. That allows you, the widescreen allows you to have a snap, so you can have a 320 snapped view and a 1024 full screen view. And you can see that's on the snap view. And then, of course, you have portrait as well. We provide both the calls to do that and also the tools in both Blend and in Visual Studio to just check what those look like, to make sure they look reasonable and your application looks reasonable. And we provide a lot of view state controls to support the changing one for the other. Talked about snapping. So we support this, again, do try it on a real tablet. It's not something I do. on a small tablet. I think, again, on a 10-inch tablet, I might do it, but I don't really, for some reason. It's, again, very interesting to try different applications and see when you use some of these modes and what you actually use them for, right? The scenario is, you have like your mail or something you're doing something in the main pane, and then you have your mail on the left-hand side and you watch your mail. I actually sort of tend not to do that. I just go for full screen. But again, that's because I have a 10-inch tablet with low resolution. If I had a high-resolution tablet, it might be different. But then if I had a really high-resolution tablet, I'd probably be able to see the snap view very well anyway. So I don't know. It just doesn't work for me. But again, it may work for you, and it may well work in your application scenario. And I've shown snapped. This is fairly obvious. You need to support a wide range of scales. And I talked about the Visual Studio design time. We also have a simulator, and I'll show you that in more detail this afternoon. But we have a built-in simulator which allows you to go and actually see how it looks and turn it on the screen. And that makes a big difference. It really is a big help in seeing what the application is going to look like. Obviously, we need to provide, and we do provide, automatic scaling. We do ask for a number of different size assets, right? So if you're going to do multiple resolution sizes, we ask for you to provide a number of different sizes of pictures, for instance, 100, 140, 180%, and then we can load whichever one is up which is applicable, right? And we're going to be talking about contracts in more detail. But there's the charms with the settings in, and then the search and share. They're all provided as part of Visual Studio. And we're going to be talking about contracts, and you're going to be building contracts yourself later on. You have the concept of a source and a target. Again, fairly obvious stuff. You need to keep a link, and you can actually. The nice thing about this is you can actually have like image sharing. You can send information like the image share, whether it's an image, whether it's data, and so on and so forth. So it's more than just copy and paste. It's actually sort of copy and paste plus context, and you can send that information backwards and forwards. Yeah, and again, search content from anywhere. We have quite a sophisticated model for finding what you're searching against. It will search through multiple applications. It will obviously search the application that's on the screen first, but then we'll search through other applications as well. And so you can find that content from anywhere in Windows, but just by going across on the search. Settings, again, put the settings, all your settings on the right-hand side. Help about terms of use, what you're actually going to use on the machine. That should all be inside there. Obviously, minimize that because you only have a certain amount of space to go up there. You can actually scroll up and down to a certain extent in the settings, but it's best to keep that down. And people expect to see a fairly standard set in there as well. So this is, again, the charms bar with the settings on the bottom. And this is a standard set of sort of things you'd expect to see in the settings, like the account information, permissions, rate review, etc. And this is the information you'd have, for instance, typical account information. Do you want to download the application updates, whether you want to do billing, all those sort of things that you can put into the charm. Okay, this is. We provide a number of standard templates for the tiles. So this is a set of examples of different tiles, right? Obviously, you can put up images if you wish as part of the tile. You can change those images. You saw that earlier on. But you can also put up the buttons on the charms as well. We provide all those as standard. You can update those. And again, that's all done automatically from calls that you make to WinRT. We provide, I think, about 12 different standard templates that you can use for information. You're not allowed to put advertising up here. That's the only thing. So, if when you actually submit your application to the store, we don't want people putting adverts up on here. It's a very obvious one, but we're not. That would not get through the procedures for the store. Again, I've already talked about this. They're the front door to your app. You can provide this ability to have secondary tiles. I showed that. You can pin, you find a particular point in your application, you can pin that, and then that becomes a secondary point into your application. It means that if somebody always wants to go to one particular part, for example, that news application, I always want to go into the technology section. That's okay because I can just pin the technology section. I may not even have the rest of it up there, right? So again, we provide that as part of the standard contracts and calls that you can make. Connected and alive. This is about the animation side of things. Update the tiles, and we'll be showing you how to do that. You can cycle through information, make sure the data is up to date. All the tiles, they all support live information, right? And also notifications, of course, as well. And we're building some, we'll put some notifications up. You can obviously put up information on the tile itself, and you can add information, the badges, to say that there's been updates. Okay, and the sort of notifications, toast notifications. You could put a notification on the tile so that you say there's an update, but you can also actually have a toast pop up. And that's when the application is not in use, okay, and you actually want somebody to really realize that something's happened, right? So typically, if it's like an email, you probably wouldn't want to put up a toast notification. If it's somebody sending an instant message or the phone ringing or something like that, you would want to put that up as a toast, an immediate access information. So as it says there, only use this as interruptive. One of the things we need to be careful about going forwards is not making the screen too busy, especially on very large screens with lots of applications on them. We need to be fairly careful, and I think people will be using the snap view more and more in order to cut down the amount of information so that they only get the relevant information. And one of the important things is around notifications. Clearly, if lots of people have toasts popping up, that will become irritating and people will turn it off. So only use it where it's necessary. And I've talked about roaming. Okay, maintain the state and preferences across the machine, push it up into the cloud, and only use that for links, small data files, user preferences, information about what the user's doing. And then finally, embrace the Metro principles. We've talked about these. I will just very quickly, although I'm aware I'm a little on time, so I'll just very quickly talk about this. There are some principles about design that we think are important. First of all, we talked about doing with less, content with Chrome, fast and fluid. A couple that I haven't talked about is actually make sure that your UI, everything looks good and crisp and clean, that everything's lined up, that things don't move around when they don't, all that sort of stuff. The stuff that I'm really bad at, I'm a designer, I'm not a developer, a developer, not a designer. So, I tend not to make sure that the boxes are lined up from one screen to the next, sort of jitters and stuff like that. It all looks really, really bad in Metro. If you don't really make sure things are pixel correct, then it can look really, really bad. The other thing is the digital side of things, authentically digital. Try not to use real world type models. So try not to use like leather or wood backgrounds and things like that. People know that your machine's not really leather, So go and use rather than a background. If you're trying to give an impression of something, use a picture rather than an image, an image rather than a text or something like that. It gives a much better impression rather than just trying to copy something in the real world. And there's a list here of resources, so you can go and see where there's more information. Anyway, that's around lunchtime, I think. That's correct, isn't it? So we break for lunch now, and this afternoon we're going to get down and look at some of the code in more detail. But I hope I've given you a quick overview of what the platform looks like and what the design on top of that platform looks like. And now we're going to look in the code this afternoon. Okay.
Thank you very much, Michael. How's it going so far? You're learning too much? Okay, so we are going to break for lunch. We have 1 hour. You will take a left outside of these doors, follow down the corridor. You can sit outside or inside, but please make sure you're back within the hour because we're going to get started right away. And one quick note, for those of you in the back, there are some seats closer to the front, and I think it's going to become more and more important as you get your hands on some code that you're closer to the screen if possible. So there's 2 here, 2 there, I think some on the side there, so don't be shy, and you can go ahead and move up closely. And last thing, we have 2 other helpers. Say hello, they're in the very back there. So if you do not have Visual Studio 11 downloaded or the Windows Consumer Preview, Windows 8, you will need to get that on your laptop in order to be able to really get your hands-on experience, and they can help you with that. Okay, so we'll see you back here in 1 hour. Thanks.